Welcome back again. I'm not going to introduce him because again, somebody else who doesn't need an introduction. Ryan Walmsley is going to talk to you about his motor controller board.
Hi, I'm Ryan Walmsley and I'm introducing my first product of the company. It's a motor controller board for the Raspberry Pi, and it's explaining it all, and we'll also be showing you how to use it. So I blog, I tweet at Ryanteck on Twitter. I run a blog at ryanteck.org.uk. I run rasptrack.co.uk, which is the Raspberry Pi map. Michael's got the t-shirt on. I haven't today. I'm the co-curator of Raspberry Pi newsletter, Pi Weekly, which the other curator up there called Ben, and he's just recently moved to the foundation. And I now am the director of Ryanteck Limited, which is my own company. So, about a year ago, I built, I'm not going to show the video, but I built a little robot, and you can search the video on YouTube, it's normally one of my robot videos. And it uses a very big board, which is bigger than the Pi, and it's just, compared to what this board is, it's messy. And the main reason why is we designed it to be able to control a robot arm using an Arduino, because this is, my dad designed it before Pi's even existed or become an idea. So, this is the original board, and as you can see, it's quite big. It's got 3 chips on it, and it can control 6 motors instead of the 2 which I'm doing, but it then requires 12 pins to be able to make it work. So the original one was designed for an Arduino. It requires extra cabling, which can get very messy on top of all the other cables needed to make a robot. It can control 6 motors. It was a lot bigger than Raspberry Pi, and the cables got easily tangled when especially you only needed to be able to use 2. The ideal board I was thinking of was make it so that it's just simple plug onto a Raspberry Pi. Budget, cheap, less than 15 quid, because there is some other boards out there and there's nothing wrong with them. It's just when you're trying to do it on a budget and in school, 30 quid a board can just be a little bit too much, or even there is a couple which are about £10 or less, but they then require extra wiring such as relays to be able to make them work. They want it to be bigger than Raspberry Pi, otherwise the Pi would just be too big and heavy to be able to use. And the main purpose, make it as simple to use as possible. So this is what I've come up with. It's a little, I'll get over to this one here. Yes. It's a little board for the Raspberry Pi. As you can see, it's smaller than the Pi. It's got 3 blocks around it. So this block here is where you get in, plug in power pins. So I'm just using on the front of it 4 double-way batteries for the motor controller's power. The Pi is on a separate power pack, so then when you're making the robot move, it don't stop the Pi from working and crash out. Oh, it's going to be. And as you can see, it's very small, and this is very simple to solder and get working. So now, I need to go back to this one here. So it's sold as a self-assembly kit, so you have to solder it together at the moment. Maybe we might make it so then you can buy it pre-assembled, but for the cheapness and to be able to get them out the quickest, we went for self-assembly. It includes all the components, PCBs, and you include a full set of instructions about to get you going with simple instructions on how to put it together, and simple instructions on how to start making a motor move. It's 26 lines of Python code. It's less, excluding all the code, but it's added in extra information to be able to make it very simple to understand. And it's currently going to be retailing in February at £12.50, including P&P. So, like I say, it clips on directly on top. Instead of you have to wire up special pins or connectors, you just get the 2 bare wires of the copper or from the motors, and you just screw them in using a screwdriver. It can support between 0.5 amps a motor, or if you're using one motor at 1 amp for the motor, you can increase it if you buy extra chips, but I'm not providing these. And you can add on extra sensors by using the breakout pins on the board. Now I'm on the setup, so okay, that's working. So I'm going to do 2 different example codes. I'm going to do the 26 line codes of Python, and then I'll be showing you how to use it in Scratch if we have time. So Oh, we've already written code. Okay, so what we've done here is opened up a text editor called Nano, and this text is a very simple to use text editor. So you just type in Nano, the file name, and then if you've got an existing file there, it'll either load it up, or if you've not got a file there, it'll create a blank file. So what we're going to do in that is we're going to import GPIO. That's better.
Thank you.
Okay, so we're going to import GPIO as GPIO. Then what we're going to do is we're going to import time, so then we can make it delay a second. Then we're going to set the GPIO pins to Broadcom mode. Okay, so what we've done there is we've set the naming of the pins to the GPIO numbers which are on the Broadcom data sheet. This is the pins which I provide on the sheet, but the normal pins also work and we'll be using them with the scratch demonstration. Okay, and now that it's set up, we need to now set up the motors. So we're just going to do one side of the robot to save time. So it is GPIO. Then the pins for motor run are 17 and 18. Okay, so that is the code needed to be able to set up the motors on the GPIO pin. Next we're going to do a while loop to be able to make them spin around. So we need to do the while true, and then this we need to do index and everyone. Okay, what we're going to do is we're going to, each pin has their own value, so we have to make sure that the other side is turned off, because if you have both sides turned on at the same time, it will do the exact same as having both of them turned off at the same time as keeping it as a full stop, and so it won't move at all. So that's why we have to do this first. Then we're going to do turning it, going to sleep 1 second in our code. And then we are going to turn on pin 13 to high.
39.
17.
Right.
Then we're going to sleep that for another 5 seconds. do with this bit of code is we're going to set the pin 17 back to off. 17's already on. Oh, that's a mistake. Thank you. That's actually one. And then we're going to wait another second. Halfway there. No, 3/4 of the way there. And then we are going to do the same with pin 18 by turning it on. And then we're going to sleep it. And that's it. So that's the bit, all the code you need to be able to get one motor moving in both directions. So what it does is, from the beginning, it imports GPIO, imports the time, sets the GPIO pins up, sets them up to output channels instead of input. Then forever, it will turn pin 17 high every 6 seconds, and then 6 seconds after that, it will turn pin, 5 seconds after that, it will turn 17 off. And then after a second, it will then reverse it and go the other way. And that's all the code you need to be able to do one motor on the board. And then to make it run, we do just a simple. Okay, so
That's me.
sorry. Okay, then which mode it's going to be. Okay.
Come back, come on. It's only on when the motor's not working.
Let's go ahead and do that now. We'll go back to Kyle.
It's on the floor.
So we should move it.
It's running off mains power at the moment. Sorry.
Tell you what.
So basically, the code is just every 4 seconds, spinning 5 seconds, spinning it one way, delaying a second, and spinning it the other. Okay, we're going to leave it to there. Okay, so we're going to just quickly reset the start. And then we'll go back, then we'll do the exact same thing in Scratch. Have I got time to do that? 5 past 4, I think.
Let's just say yes. I'm on time. What time is that?
10 minutes left.
That is yes.
Okay, so what we've done there is just clean up the pin for the next demo. So we're going to exit out this, and we're going to go to Scratch, which I need to kind of quickly run and get in for a big possible. So I'll be back in a second for that. Okay, just go for a key card over. Aha. Okay, this won't take anywhere near as long as the other one because this is very simple using Scratch. It's actually simple. Aha. So this is using the modified Scratch. Okay. And that's working, that's good. So we're just going to do, we're not going to do both ways, we're just going to do one way. We're going to drag forever. That way the green flag is picked. And I believe it is water. So we're going to do pin. And on this number it's actually 11. And I think it's high. And then we're going to do delay. And then this should start making it work. Hopefully. So, yeah. It's actually simpler to do in GPIO. Actually, I've made a mistake, it's not turning off. This one, I'll try and do one hand. Next. Okay, so then it's just the same broadcast. New broadcast. In 11 low. Are you asking? Thank you. There. So that's the same code, it's just doing it with using GPIO. And then it's as simple to be able to then make it go around the other way, just by setting the other pin on. And to be able to control the other motors, it's as simple as just doing different pins as well. Okay. That's finished. Okay, that's enough of the Python. So that was our quick demonstrations of being able to set up the board to be able to control one motor using Python and the same code using GPI, Scratch GPIO by Simon Walters. So I've been testing outside in the demonstration area. The demonstration I'm showing is the robot being controlled by another Pi using some network code that David Weller has written. And I'll be posting how to do this as a project using the board as well. And I've also got some of these instructions if you're interested to come and look at how the code works fully. We finished the fundraiser for these boards 2 weeks ago, so we are hoping to have them in stock by the end of February, so it's probably not going to be the next Cambridge Jam, but the Jam after that I'm probably going to hopefully be able to bring some for you to buy, if you want to buy one. And so yes, so it will be depending on the date. Does anyone have a question about it, or robotics in general?
Why are you using 2 pins for the motor?
The reason we're using 2 pins is because the board requires a separate pin for each direction it goes in because it's a bi-directional.
Bi-directional motor?
Yeah.
Right.
So you don't have to use any extra wiring to be able to go in reverse. You don't need any extra relays or anything on top. It's just as simple as turning, instead of turning pin 17 high, you're turning pin 18 high to go in reverse. Any other questions? Yeah.
How did you get into the commercial world and actually sell your product?
For this, I had only half of the money to be able to build these myself, being a new company. So we used a site called Tindy. I can get them up. So Tindy are a mix of a Kickstarter site along with a eBay for electronics. I think is how they advertise themselves in this way, I don't know. Basically, so like I said, it's a Kickstarter site, and we require 50 pre-orders to be able to make them possible at the cheap enough price. Because one of the main things was to be able to get it cheap enough, and so we had to have 50 orders, and we had 138 in the end. So we had enough to be able to make it cheap enough and at the price budget we wanted to. That's one of the best bits about the board is that. Not only is it cheap, but it's also fully made in the UK. So, not all the components are made in the UK, but the main components, and it's going to be all sent out from the UK and put together in the UK, pretty much. The main components of the PCB is made in the UK as well. Any other questions? Yeah.
When you're connecting the two different GPIO ports, what you're doing is it just swapping the voltage of the motor, right?
Yeah.
It's just plus VDD, one pin, minus VDD.
Yeah. So instead of it being plus on one pin all the time, it's then going from 17 being at high voltage of 3 volts, and then then the motor driver then putting 5 volts on the same pin on the side, and then it's swapping around. Any other questions? No? That's it. Thank you.